Hi everybody. So you have a couple of worksheet packets. One of them I'd like you to look at right now is the one where the first page is pH calculations, and the second page you'll notice is a review of our naming acids and bases, as well as doing some product prediction. So I'd like to just quickly cover and remind you guys on nomenclature for our acids. Okay. All right. So we know that acids are compounds that form H plus in water. We recognize them generally because we say they have hydrogens in the front of their formula. And a few examples: hydrochloric acid, nitric acid. But what we got to remember is the ending to our anions so that we remember how we are supposed to name that. So an IDE ending suggests that I came from the right side of the staircase. So that generally means I'm dealing with a monatomic ion. Remember, that's made up of a single element. And so I need to do hydro in the beginning. And my ending will get changed to ic, and then I add the word acid. So hydrochloric acid, HCl. All right. So the Cl is a monatomic ion, so that's why there's hydro in the front. And we change the ide to ic, and then we add acid, HCl, hydrochloric acid. If we're an ATE ending, that means I came from the polyatomic ion list on my periodic table. So we could take a carbonate ion, CO3 negative 2. A carbonate ion, if it's a polyatomic, we don't use hydro, so we just say carbonic acid. We drop the ending of the anion, add ic. Now, what if I had less oxygens than my normal, so I had an ITE ending? So that would be something like a phosphite ion. So a phosphate ion is PO4 negative 3. A phosphite ion is PO3 negative 3. So now that I'm an ite, I change my ending to us so that I know that I'm dealing with a polyatomic that has lost an oxygen. So that would be phosphorus acid, not phosphoric acid. That's how you tell the difference between those two. Okay, so remember, 8, I always think of 8 having more oxygens. Ite always has less, with per having the greatest number of oxygens, and hypo having the least number of oxygens. Right, so our most common one that we're going to see on the periodic table, let me just fill all of this in. Our most common one that we see on is the one I gave you on the periodic table inside of that chart, ATE endings. So a chlorate ion is a great example, ClO3. Well, sometimes a chlorate gains an additional oxygen. So we add per to the beginning, so it becomes perchlorate. So it's ClO4 minus 1. So that would be perchloric acid. Then there's chloric acid, which is HClO3. Sometimes a chlorate ion can lose an oxygen and become a chlorite ion. So this now becomes chlorous acid, HClO2, negative 1. Well, HClO2, please excuse me. And then sometimes the chlorate can lose 2 oxygens, so it becomes hypochlorite. So now it becomes hypochlorous acid, which is HClO. Okay? A lot to remember, but we're going to need to know that so that we can properly look at our reactants, name them, and predict our products. All right, we can just do a couple here real quick. HBr, I hope you would choose that it's hydrobromic acid. H2CO3, I just went over that one, carbonic acid. H2SO4, sulfuric acid, and H2SO3, sulfurous acid. Thank you.